My name is Joe Soughayer, and I am the Manager of Business Development at IonOptix. We started in 1990 as a company primarily focused on quantitative calcium measurements, and we morphed through a relationship that our founder had with the cardiovascular industry quickly into measuring excitation contraction coupling of cardiomyocytes. The instrument that we're highlighting here is the cardiac slice system. It's a new system for us. It allows us to measure force, measure calcium, and importantly, it allows us to control force by clamping the preload and afterload during force measurements. And that allows us to look at things like diastolic filling and other parameters related to the mechanics of heart muscle. So the cardiac slice system is designed to enable everything from preparation to data acquisition to data analysis. So we've included a bunch of accessories that are necessary for the preparation side. In terms of the data acquisition, the hardware, we've got a fast force transducer, and the speed of the force transducer is relevant because we need to be able to clamp the force. We've also included a fast programmable motor, a magnetic voice coil motor, that allows us to shorten and lengthen the tissue at preload and afterload. It also includes a chamber that has platinum stimulation wires for electrical stimulation, field stimulation, and perfusion. The system also includes software that allows you to control the preload and afterload forces to generate work loops. And importantly, it also includes analysis software that's specific to the application. Cardiac slices better preserve the native architecture of the tissue. Unlike isolated cardiomyocytes that lack neighboring cells and extracellular matrix proteins, the cardiac tissue better preserves the physiology of the heart. And unlike whole heart, it's much easier to control certain parameters like mechanical load, while also being able to interrogate things like sarcomere length and calcium. So the cardiac slice enables physiologic measurements that wouldn't be possible or would be very, very difficult in other model systems. So for people that are looking at specific phenomenon related to the mechanical loading of the heart, the cardiac slice model is a much better preparation. So our system enables those sorts of measurements, and the cardiac slice preparation is so much easier to prepare than isolated myocytes, which have a lot of variability and heterogeneity in them, which means that the end user will have more reliable and reproducible data to analyze. So following what I previously said, the ability to do specific perturbations, including controlling the mechanical load on the tissue, which would be very difficult in other model systems like the isolated myocyte, like the whole heart, enables our users to investigate things like diastolic filling and other mechanical properties that are too difficult in other model systems. So there are a couple significant advantages that are usually a little bit hard to recognize at first, and I think those are the ones that are important to feature. The ability to make measurements and see the data in real time is imperative for these studies. Oftentimes there are experimental challenges that crop up and adjustments that need to be made. And these model systems, whether it's isolated myocytes, whether it's whole heart, whether it's cardiac slices, these are very valuable model systems. And if you cannot make adjustments quickly, you'll end up having to throw data away. And you won't be able to reuse that tissue for any other purpose. So having real-time data acquisition, being able to see what's happening in real time, allows you to make changes quickly in order to get reliable data, reproducible data effectively. The other thing that's really important that distinguishes our systems from other systems similar to it is the acquisition speed. Being able to sample at very high frequencies means that we oversample our data appropriately and we don't undersample data. Undersampling data results in data loss, like you will lose the peak because you won't have enough data points to fully resolve it, or you'll lose transitions. And that in turn would make your data less reproducible or irreproducible entirely. So real-time measurements and very fast acquisition rates differentiates our systems from others.